Hello everyone, I am Dr. Munish Bharadwaj from School of Engineering and Technology of IGNOU. Today we will discuss types of cement. In this, we will be discussing different type of cements, field test to be done on the cement, and briefly I'll enlist basically what are the different laboratory tests. So here the learning outcome of this discussion will be that after watching and listening to this discussion, you should be able to explain different type of cements, their properties, what are the field tests that are done, and what are different tests that can be done in laboratory. Now let us begin with types of cement. Basically, there are many types of cement, but here we will be discussing 12 important types, like ordinary Portland cement, which is abbreviated as OPC, rapid hardening cement, rapid hardening Portland cement, which is abbreviated as RHPC, low heat Portland cement, sulfate resisting cement, blast furnace slag cement, white and colored cements, high alumina cement, hydrophobic cement, then pozzolana cement, oil well cement, then expanding cement, and quick setting cement. So these are the 12 different type of cement that we will discuss now. Let us take these cements one by one. As you know that by changing the chemical composition, I mean the percentage of the different box compounds, if we change their percentage, we can get different type of cement. So with this knowledge, let us move to the properties and uses of different type of cement. Let us take first the ordinary Portland cement. What are the properties of ordinary Portland cement? Ordinary Portland cement or OPC is also called as normal setting cement. It is general purpose cement which is suitable for all type of general concrete construction works. Means you can use this cement in all type of construction works. This cement is characterized by medium rate of strength development, and also here the heat generation is also medium. Means here the heat of hydration is medium, also the rate of strength development is also medium. This cement is less resistance to chemical attack. Now, how this ordinary Portland cement is classified? Ordinary Portland cement are classified into different grades basically. As per IS codes, there are 3 grades of OPC. First is 33 grade cement as per the guidelines or specifications of IS code 269 1989. Next is 43 grade cement. The specifications of this cement are given in IS code 8112 or 8112 1989. Next is 53 grade OPC cement. Specifications of this cement are given in code IS 12269 1987. So these are the 3 main grades of the cement. Now, as per the IS code 10262 1982, these OPC grades are also given based upon the compressive strength of the cement, and the OPC is classified here in 6 categories: grade A, grade B, grade C, grade D, grade E, and grade F. These are the 6 grades given in IS code 10262/1982. Now let us see what are the compressive strength of these grades. Compressive strength of grade A. Now here it ranges from 32 to 37.5 MPa or Newton per mm square. Grade B OPC cement, here the compressive strength ranges from 37.5 to 42.5 MPa megapascal. Then grade C, the compressive strength ranges from 42.5 MPa to 47.5 MPa. Then grade D OPC is compressive strength here 47.5 MPa to 52.5 MPa. Grade E OPC, it has compressive strength range 52.5 MPa to 57.5 MPa. And grade F OPC, compressive strength range is 57.5 to 62.5. Here you see that those three grades, 33 grade, 43 grade and 53 grade. Now in which categories of these grade A, grade B, grade C and grade D, grade E and grade F, these our earlier three grades fall. Let us see 33 grade. It is having 33 MPa compressive strength. So you just see the grade A. Grade A is having the range 32 MPa to 37.5. So this 33 grade cement, which for which the specifications are given in IS 269/1989, this will fall in grade A category. If we look at 43 grade, then you just look at the grade C. It is having range 42.5 MPa to 47.5 MPa. Then it will belong to this 43 grade cement will belong to the grade C OPC as per IS 10262/1982. If we look at 53 grade, this 53 MPa strength is in the grade E category because here the range is 52.5 MPa to 57.5 MPa. So here this 53 grade cement will belong here now to the grade D category. So that way is the classification of the ordinary Portland cement OPC. Now, what are the uses of OPC? Ordinary Portland cement is used in all important structures where great strength is required, such as heavy buildings, bridges, etc. It is also used in structures subjected to the action of water, such as foundations, underwater reservoirs, watertight floors, dockyards, etc. OPC is also used for making cement mortar, plain cement concrete, reinforced cement concrete, for making plaster, for painting purpose also this cement can be used, and it is also used for drainage and water supply works. Now let us see the next type of cement. Next type of cement is our rapid hardening cement. Let us see the properties of rapid hardening cement. Rapid hardening cement is similar to ordinary Portland cement but with higher tricalcium silicate. Means here the C3S content is higher in comparison to the OPC. And also if you look at the grinding, here in RHPC or the rapid hardening cement, basically the grinding is finer. Means the cement particles are more fine. Rapid hardening cement gains strength more quickly than ordinary Portland cement, though the final strength is only slightly higher. Means in the final strength there is not much difference, but rapid hardening cement gains the strength quickly. The rate of gaining of strength is fast, more. Rapid hardening cement is also called as high early strength Portland cement because here it is gaining strength at early stage. How much early? You can see that 1-day strength of this cement is equal to the 3-day strength of ordinary Portland cement with same water cement ratio. Means if we are using the same water cement ratio and if we compare the strength of these two cements, then rapid hardening cement will gain the same strength in 1 day in which the ordinary Portland cement gains the strength in 3 days. Also, if we compare the cost of the rapid hardening cement and ordinary Portland cement, then rapid hardening cement is 10% costlier than ordinary Portland cement. What are the uses of rapid hardening cement? As it is clear from its name, rapid hardening means it gains strength early. So it helps in the situations where the formwork has to be removed early and it is to be used at other places. Means you can relieve the formwork early by using this type of cement. Then rapid hardening cement is also used where the high early strength is required, where you want to open the structure or want to use the structure early, at early stage. Also, this cement is used for constructing road pavements where it is important to open the roads to the traffic quickly, because you cannot obstruct the traffic for a long time. So here we have to open the road to the traffic at early stage, as early as we can do. So the only option we have here is the use of the rapid hardening cement. This cement is also used in prefabricated construction products like prefabricated slabs, prefabricated posts, electric poles, etc. because the molds can be released quickly here. One more use, we see that it can be used for the cold weather concreting, because rapid evacuation of heat during the hydration protects the concrete against freezing. What is the problem in cold weather concreting? Basically, that there, because of the low temperature, the water which we are using to make concrete, it become ice, it freezes. And you know that water is very important for completion of hydration process, and without completion of hydration process, the cement will not gain the strength, concrete will not gain the strength. So here it is important that the hydration process is completed quickly. So for that purpose we use the rapid hardening cement in cold weather concreting. Next type of cement is low heat Portland cement. What are the properties of low heat Portland cement? In low heat Portland cement, percentage of tricalcium silicate, that is C3S, and the tricalcium aluminate, that is C3A, the percentage of these two compounds is lower than the ordinary Portland cement and also the rapid hardening Portland cement. So in comparison to these two cements, this low heat Portland cement is having the less percentage of C3S and the C3A, because these two compounds are mainly responsible for generation of heat. But percentage of dicalcium silicate, C2S, is higher in this cement. What is the effect of this composition? Basically, this composition results in a slower rate of reaction, lower evolution of heat of hydration, and low early strength. So this is the effect of this composition. But here the ultimate strength remains more or less unaffected. Means here the ultimate strength is almost same as in OPC. What are the uses of low heat cement? Low heat cement is used in large mass concreting works such as dams, bridges, abutments, and retaining walls. Basically, these are the structures where the large volume of concrete is used. And if large volume of concrete is used, if we are using other type of cement, large amount of heat will be generated. and if it is a large amount of heat is there, then cracks may occur. So to avoid that, we are using in these mass concreting works, we are using low heat Portland cement. Low heat Portland cement is also used in works where the rate of heat of generation must be capped to minimum. Now let us see another type of cement. This is sulfate resisting cement. The properties of sulfate resisting cements are that this cement, also known as super sulfate cement, this cement has percentage of tricalcium aluminate below 5%, very less, and it results in the increase in resisting power against the sulfate attacks. Here we are having that percentage of tricalcium aluminate is lower than 5%. This basically helps in increase in resisting the power against the sulfate attacks of this cement. Now let us see what are the uses of the sulfate resisting cement. Sulfate resisting cement is used for canal lining in severe alkali conditions, especially in the arid western regions. Wherever the structure is likely to be attacked by the alkalis, there this cement will be used. As I gave you this example of canal lining, and especially that too in the arid western regions of the country. This cement is also used for marine works, mass concreting jobs to resist the attack of aggressive water. Because in marine conditions, the water is having lot of chemicals, lot of sulfate and other alkalis. So if the proper type of cement is not used, then those alkalis or these aggressive chemicals will attack the concrete and it will damage the concrete. So here in such conditions we are using the sulfate resisting cement. This cement is also used for works underside of bridges, because underside of bridges they are exposed to the gases which may have the chemicals which are harmful basically to the concrete. Also to the over the railway tracks and for concrete sewers which carry the industrial effluents, because industrial effluents are having lot of chemicals which may attack the concrete. This cement is also used in the construction of reinforced concrete pipes and also for construction works to be done in sulfate bearing soils. So these are the uses of this cement. Next is blast furnace slag cement. So what is blast furnace slag? Blast furnace slag is a waste product obtained during manufacturing of iron. It contains all the basic elements of cement, that is silica, alumina, lime, iron, etc. Means all the ingredients of cement it also containing basically. So that way we can use it for making the cement. What we do with this blast furnace slag, we crush it preliminary to a granulated form, means we crush it to form a grains basically, which is then mixed with cement clinker. Means we will be adding cement clinker to this granulated material, and the proportion of the cement clinker and the slag will be 65% of slag and 35% of clinker. Then after mixing it, this will be grounded together to form the cement, and this cement which is produced by mixing and grinding the blast furnace slag and the clinker, that we call as blast furnace slag cement. Why it is being used? Basically because it is cheaper than ordinary Portland cement. This cement develops low heat of hydration and also has less early strength. Next is uses. Blast furnace cement is used for mass concreting works such as retaining walls, bridge abutments, dams, etc. Also, it is used for all purposes for which ordinary Portland cement is used. Now let us take the next cement, white and colored cements. What is white cement here? How it is manufactured? White cement is manufactured from special raw materials like white chalk and china clay, which is having low contents of iron oxide. Low content means here it is less than 1%. Colored cements are manufactured by adding suitable mineral pigments. These are oxides of lead and other materials to the Portland cement during grinding. Means at the stage of grinding, we will mix the oxides of lead and other materials to get the colored cement. Whatever color we want, accordingly we will be use that type of oxide basically. The proportion of the pigment vary from 5% to 10%. Means here in this, how much pigment we will be adding, that proportion will vary depending upon that color. Basically that will be 5% to 10%. Here, what are the different colors contributed by different chemicals or the minerals? Let us see the cobalt. Cobalt gives blue color. If we use iron oxide, then in different proportions it will give different color. Means we are using the same oxide, but even by changing the proportion we will get different color. Just like brown, red or yellow color. All these three colors you can get by changing the amount or the proportion of the iron oxide that you will be mixing to the OPC at the time of grinding. Then manganese oxide, it will give you black or brown color in the cement. These cements are costlier basically than ordinary Portland cement. Why? Because a specific requirement which we are imposing upon the raw material and the manufacturing process. Because here, if you compare the raw materials here, the raw material is not same as the OPC. It is different basically. So this getting those raw materials increases the cost of cement here. And manufacturing process is also bit different. So this raw material and the manufacturing process, this makes these cements little bit costlier. What are the uses of these cements? These cements are used in decorative works, such as finishing coat of the concrete floors. If you want to give the colored concrete floor, then you can use the colored cement. Then face plaster to the walls. If you want to have the colored walls, so you can use the colored cement basically in the plaster. Also, these cements are used to make mortar, which will be used for the floors and wall tiles and for ornamental concrete works. If you want to have decorative and ornamental concrete works, so in that you can use the colored cement basically and the white cement. Next is high alumina cement. High alumina cement is produced by grinding clinkers formed by calcining bauxite and lime. Bauxite is an ore of aluminium. The proportion of alumina varies from 35% to 45%, and the ratio of alumina to lime is in between 0.85 to 1.3. This is the proportions basically. It is not only rapid hardening cement but also a higher ultimate strength cement. Means it hardens rapidly, also gives high ultimate strength. These are the very important properties of the high alumina cement. This cement resists the action of acids and can withstand high temperatures also. So that way also this cement is very important. That you see here that it can resist the action of acids and also it can withstand the high temperature. But if you compare the cost of this cement with OPC, it is costlier than the ordinary Portland cement. Now, what are the uses of high alumina cement? High alumina cement is very useful for chemical plants because you know that it can resist the attack of acids. So it is used in the chemical plants and lining of furnaces because it can resist, it can work up to a high temperature basically. So that way it is used in the lining of the furnaces because in furnace very high temperature is there. So this cement can be used in such situations. High alumina cement is also used for structures subjected to the action of seawater, chemicals and other such agents. Because seawater, again, as you know, that having lot of chemicals, so there this cement can work well. Now next type of cement that we see is hydrophobic cement. Hydrophobic cement contains admixtures which decrease the wetting ability of cement grains. Means it decreases the wetting ability. If the cement grains are coming in contact with the moisture, then moisture will be not having much effect basically, because here the wetting ability of the cement grains is decreased. Hydrophobic admixtures like oxidized petroleum, acidol, etc. form a thin film around the cement grain. This is the basically the action of this cement basically. What happens that a thin film is created around the cement grain by the compounds which are using as admixtures. When water is added to the hydrophobic cement, the absorption films are torn off the surface and they do not in any way prevent the normal hardening process of the cement. That you can question here that when it is hydrophobic cement, then it will not be reacting with water. But I am explaining here that when water will be added to this cement, that absorption film which is created around the grains of the cement, this is torn off the surface, okay, and that water will penetrate and hardening process will be done as normal. In initial stage, the gain in strength is less as hydrophobic film on cement grain prevent the interaction with water, but the strength of hydrophobic cement after 28 days is equal to that of the ordinary Portland cement. Let us see what are the uses of hydrophobic cement. Hydrophobic cement is used in structures where high frost resistance or water resistance is required. It is also used in humid places where storage of ordinary Portland cement causes deterioration in the quality of the cement. So these are the uses of the hydrophobic cement. Next we take the pozzolanic cement. Pozzolanic cement, basically pozzolana is a volcanic powder, means the material obtained from the volcanoes. This pozzolana resembles surkhi. It resembles with surkhi, which is prepared by burning bricks made from ordinary soils. It can also be processed from shales and certain type of clays also. The pozzolana material should be between 10 to 30% in the formation of the pozzolanic cement. Now let us see what are the uses of pozzolanic cement. Pozzolanic cement is used in sewage works and for laying concrete under water basically. It is also used for marine structures. Now next cement is oil well cement. This oil well cement is a special type of cement which is required for sealing of oil wells. Means for the sealing purpose of oil wells, this oil well cement is used. Why sealing is done? Sealing is necessary to prevent the sides of the freshly drilled well from collapsing and to keep the groundwater out of the well shaft. When we are drilling the wells basically, so wall of the wells can collapse basically. To prevent the collapsing and also to keep the groundwater out of the well shaft, we use the sealing. We do the sealing basically, and this sealing of the oil wells is done with the help of the oil well cement. Oil well cement is manufactured by adjusting the proportion of iron oxide so that all the alumina is converted to tetracalcium aluminoferrite C4AF. Tricalcium aluminate C3A is formed in a small amount, and thus the setting time of the cement is increased. Because the setting time is primarily governed by C3A, and here the C3A means the tricalcium aluminate is in less amount, so here the setting time is increased for this cement. Let us see what are the uses of oil well cement. Oil well cement is used for cementing the oil wells. It is also used to protect the oil well casing from corrosion. Now next type of cement is expanding cement. Expanding cement is manufactured by adding an expanding medium like sulfoaluminate and a stabilizing agent to the ordinary cement. This cement expands whereas other cement shrinks. This is the major drastic change in the property. Thus this is the cement which expands whereas all other cements shrink. Let us see what are the uses of expanding cement. This cement is used for repairing the damaged concrete surfaces. Because if there are cracks, if you use this cement, then after placing, when it hardens, it will expand and it will fill all the spaces. So that way it is used for repairing the damaged concrete surfaces. It is also used for construction of water retaining structures. Just to avoid that any minor cracks are also not there in the water retaining structures, this cement is used because it will avoid all possibilities of even minor cracks. So that way this cement is used. Now the quick setting cement. Quick setting cement is manufactured by adding a small percentage of aluminium sulfate and by finely grinding the cement. This cement has the low percentage of gypsum or retarder for quick setting action of the cement. The setting action of the cement starts within 5 minutes after addition of water, and it becomes hard like stone in less than 30 minutes. So that way it gets its name as the quick setting because it sets very quickly. You see here that its initial setting time is 5 minutes and its final setting time is not more than 30 minutes. It is used to lay concrete under the static water or running water. So here we covered all 12 type of the cements basically. Now let us see the testing of Portland cement. Why do we need the testing? The quality of concrete depends upon the properties of cement. So if the properties of cement are good, then we will get the good quality of concrete. So first of all, how do we do the sampling? The samples are collected from at least 12 different bags or barrels or containers or from 12 different positions in a heap if we are using the loose cement. The quantity of cement is so collected is intimately mixed and the final sample weighing at least 5 kg is prepared. Then it is stored in airtight container till the tests are done. What are the tests that is done on the Portland cement? We do the two types of tests. Field tests means which we can do in field. Lab tests which are done in the laboratory. Let us see what are the field tests. First is color. That for good quality of cement, the color of the cement should be uniform. Same color throughout the bag. It should be grey color with a light greenish shade. Fresh cement or the good quality cement should have the light greenish shade with grey color. Then lumps. We have to check the cement for presence of any lump. Cement should be free from any hard lumps. Such lumps are formed by absorption of moisture from the atmosphere. Any bag of cement containing such lumps should be rejected because it means there is a exposure of the cement to the moisture and there is a deterioration of the cement. Next is smoothness. We can check the smoothness of the cement. Cement should feel smooth when touched or rubbed between fingers. If it is felt rough, it indicates the adulteration with sand. Means somebody has done the adulteration and sand is mixed with the cement, then only you will feel the rough basically. Then we should check for the temperature. That if the hand is inserted in the bag of the cement or the heap of cement, then you should feel cool and not warm, because warm means some moisture has gone into the cement and pre-hydration is there basically. Then only warmness will be felt. Then next is, if a small quantity of cement is thrown in a bucket of water, the particles should float for some time before it sinks. Means the particle of the cement should not sink immediately, they should float over water for some time before sinking. Next is, a thick paste of cement with water is made on a piece of glass plate and it is kept under water for 24 hours. It should set and not crack. Next is that a block of cement 25 mm by 25 mm and 200 mm long is prepared and it is immersed for 7 days in water. It is then placed on supports 15 cm apart and it is loaded with a weight of about 30 kg. Then the block should not show any sign of failure. Next is the briquettes of a lean mortar. Lean mortar means in which we are using 1:6 proportion of 1 cement and 6 sand is made. The size of the briquettes may be about 75 mm by 25 mm by 12 mm. They are immersed in water for a period of 3 days. If cement is of sound quality, such briquettes will not broken easily. So this will tell you that cement is of good quality. So these tests you can use for field test. In field you can check the quality of the cement. Now let us see what are the different laboratory tests which we can do in the lab. Laboratory tests for examining the suitability of cement are chemical composition, fineness, consistency, setting time, soundness, compressive strength and tensile strength. These tests are done in the lab to examine the suitability of cement. These tests we will discuss in our next lecture, how they are done, what are the results, what are the requirements. Basically all these we will discuss in the next lecture. So in this lecture we discussed about the different type of cements, what are their properties, what are the uses of different type of cements, where they are suitable basically. Then we discussed that what tests should be done for checking the quality of the cement, we discussed different field tests, and I just gave you the names of different laboratory tests that can be done to examine the suitability of the cement. Thank you for watching and listening.